Hello, we're going to start with a quick review of trigonometry, basics around the triangle, how the trig functions are related, and then we're going to jump into finding derivative of inverse trig functions, understanding them graphically, and then setting up a few integrals that we can now solve using inverse trig functions. Last week we saw how to use arctan, but there's a whole family of inverse trig functions that we can actually use. So let's go through the details of this. It'll be pretty fun. So in a right angle triangle, if this is your angle theta, and here is your right angle, you have sides. We're going to make this hypotenuse here a size of length 1. That's typically how we do it. I'm going to call this here x and this here y. And the trig functions, when we're applying for these particular values, we have, of course, that cosine of theta is going to be the adjacent side divided by the hypotenuse. That'll be x over 1. We're going to have the sine of theta, which is going to be the opposite side divided by hypotenuse, y over 1. And then we're going to have the tangent of theta, which is going to be the opposite over the adjacent, y over x. And then we have the other trig functions that are defined in terms of these three. So secant theta, which is 1 over the cosine, is going to be 1 over x. Cosecant theta, which is going to be the inverse of sine, so it'll be 1 over y. And cotangent of theta, which is going to be the reciprocal of tangent, so x over y. So this is your basic relationship in the right angle triangle. The important piece here is we really want to start and get a better understanding of what the inverse trig functions mean. So if I say theta itself is the cosine inverse of x, I'm not drawing this picture. I'm drawing a different picture. And let me show you the picture that I'm drawing for this statement. So cosine inverse is an angle. It's an angle theta. And if x is what we plug into the cosine inverse, it means that cosine of this angle has to be x. And remember, cosine mean x over 1. So this is going to mean that if I have my angle theta right here, I have my right angle triangle, the length of the hypotenuse is 1, this is going to be x. Because we have a right angle triangle, we can use the Pythagorean theorem to find the length of this side in terms of 1 and x. And we have, if this is my y and I solve for y, I'm going to get that 1 equals x squared plus y squared. And so I get 1 minus x squared equals y squared. So that y is the square root of 1 minus x squared. This means that if I plug in this very angle theta into sine, I'm going to get y over 1. So I'm going to get the square root of 1 minus x squared. Solving triangles this way and solving the relationship within the triangles means that we can take the inverse trig functions and plug it into other trig functions. So this means that the sine, say, of the cosine inverse, which is the arc cosine of x, is going to be the square root of 1 minus x squared. Okay, we're going to use this technique very much right now because what we're trying to figure out is what is the formula for the derivative of the inverse trig functions. So we're going to do it for three specific inverse trig functions. We're going to do it for arc sine of x, arc cosine of x, and arc tan of x. We want to find what those derivatives are. So let's start with how we go about finding the derivative for arc sine. So suppose we do the following. We're going to let s of x be arc sine of x. Okay, we're just going to call it s of x right now, because when we write sine inverse of x, we want to do math with it. But it's not helpful here. We want to hide the math meaning of it behind a symbol, and then we're going to manipulate that symbol to get something useful for the derivative. So this means that if I plug s of x itself, so if I take s of x and I plug it into sine, because they're inverse functions, they cancel out. And we just get x back. That's really the definition of what it means to be an inverse function. Now, what we can do is we could take the derivative of both sides with respect to x. And we're going to do that. So let's say we take the derivative here. It should equal the derivative there. The derivative of x with respect to x is just 1. The derivative here, we have to apply the chain rule. So the derivative of sine is cosine. We plug in s of x, and then we multiply by the derivative of the inside, which will be the derivative of this s of x function. On the right, the derivative of x is just 1. This trick works because now we find s prime. We just have to solve for it. So we're going to get s prime of x is 1 over the cosine of s of x. And it doesn't look like we've made much progress because we still don't really know what s of x is. But now we're going to remember that s of x is arc sine. And remember that arc sine is an angle, and it's the angle in this picture. It's exactly this theta, so that here I have x and here I have 1. Because this is the arc sine, and for this angle, sine is opposite over hypotenuse. So this angle is this one. If we plug this angle into cosine, cosine is going to be this length divided by this, by 1. And so we just solve the triangle like we just did, and we get the square root of 1 minus x squared. And so now we can actually replace cosine of the arc sine of x by just the square root of 1 minus x squared. And this is, in fact, the formula for the derivative of arc sine. So we have that the derivative of arc sine is 1 over the square root of 1 minus x squared. Well, that's just cool. OK, let's take a look at arc cosine and see how different that argument is. Since I'm looking at cosine, I'm going to call this function c of x. And this is going to be the cosine inverse of x. And of course, this time, in order to undo it, we plug it into cosine. So the cosine of c of x must equal x back. That's what it means to be the inverse function of cosine. So we have cancellation happening. We take the derivative of both sides, prime, prime. And applying the chain rule on the left, we get derivative of cosine is negative sine. The derivative of c of x will be applied outside, and that must equal 1. And so here we have this negative sine of c of x. So c prime of x is negative 1 over the sine of c of x. Okay, great. But what is the sine of c of x? Well, we have to draw a picture. Right angle, I can do this. We have our angle theta. This angle is c of x. That's what this angle is. And because x is what we plug in, x has to equal the cosine, right? So the cosine itself of this theta is going to be x divided by 1, because cosine is adjacent over hypotenuse. That means this length is now x, this length is 1. Solving using the Pythagorean theorem gives us 1 minus x squared here once again. And so when we take the sine of this angle, we now get root 1 minus x squared over 1. So that means that c prime of x is negative 1 over the square root of 1 minus x squared. And now we have our second derivative. We have the derivative for arc cosine. So our cosine prime is negative 1 over the square root of 1 minus x squared. And yeah, sine and cosine are intimately related. So it makes sense that their arc cosine and arc sine's derivative are very similar as well. All right, let's do the third one of these. Let's go over to tangent. For tangent, I use t of x, and this will be arctan. And this time, in order to undo it, we plug it into tangent. So the tangent of t of x has to give us x back. Now, our picture is going to be a little bit different, so I'm going to erase my triangle once more. We take the derivative of both sides. The derivative of tangent is secant squared. We still plug in tangent of x, t of x, but then we multiply by t prime of x. And that equals the derivative of x, which is 1. So this means that t prime of x is 1 over the secant squared of t of x. Okay, so how do we find t of x or secant squared? Well, we have to draw our picture, and we have to make sure that it matches up with the things that we know. So this angle is t of x. This is the arctan. And because x is what we plug in, if we plug this into tangent, we get x over 1. Tangent is opposite over adjacent. So if this is x and this is 1, this here will be the square root of 1 plus x squared by solving using the Pythagorean theorem. This is important because what we're doing is we're going to be plugging this angle here into secant squared. And secant is going to give us hypotenuse divided by adjacent, because it's 1 over cosine, right? So I could rewrite it if you wanted as cosine squared of t of x. And that's going to give us the following. T prime of x will be 1 over. So secant of this angle is going to be root of 1 plus x squared. And then because secant is being squared, I just have to square it. And so I get 1 over 1 plus x squared. So 1 over 1 plus x squared is the derivative of arctan. All right, I'm running a little bit out of time on this particular video. So I'm going to cut here, and then in the next video, I'm going to show you how to use these results to solve some integral problems. See you then.